one basic function that's transformations are out the window. Just one. Which function is this?
Square root.
Very good. Awesome. Now I compare the first one. Don't look at the second one. That's a different story. So I need to identify, again, if it's a transformation on x or a transformation on y. A reflection that is a transformation on x will be reflecting x with respect to the y-axis. It's positive here, it's negative here. Now, a transformation on y will be a positive y changed into a negative y, or a negative y changed into a positive y. So we can have two types of reflections with respect to the y-axis when I change x, or with respect to the x-axis when I change y into negative y. So negative x into positive x, or vice versa. I would say negative x into negative x, or y into negative y. So now I have to identify if this is a transformation on x or a transformation on y. I'm comparing the inside. I'm comparing the function. It's the same. This negative does not touch x. It's completely outside. So the function is the same. This one has plus in front and this one has minus in front. So then what type of transformation is it? What am I changing? Am I changing y or am I changing x?
Y.
Change in y. Excellent. If it's a change in y, it's a reflection with respect to the x-axis, from positive y to negative y. So reflection, or reflect, WRT, this is how lazy people write with respect to the x-axis. Okay? So then when I graph, I have to start with a base function, or a basic function. Here's the graph. But this f of x will reflect y into negative y. So when I graph, as we said, with respect to the x-axis, here it is. This is the graph of negative, the square root of x. All these heights are positive, but all these heights are negative. So this one, I don't know if you see the color correctly or not. So this is the negative, the square root of x. Finally, I'm looking at g. What am I changing in g? It's a different story. I have, in the base function, I have x, but in the other one, I have negative x. So the sign touches x. It must be a transformation on x. We have no secrets here, because then we have negative x greater than or equal to 0. All this quantity has to be positive. And when I multiply both sides by negative 1, I get x less than or equal to 0. So I know it must be a reflection with respect to the y-axis. So here's the graph. This is the graph of the square root of negative x. And the domain is 0 to negative infinity to 0. So here it is. I'm putting the symbol on top of it. You don't have to. It's just to make sure that you understand where it starts and where it ends. Okay, let's look at the combo and then the last two. Any questions for me? Don't be shy, please. Any questions? Okay, last type. Oh, maybe we should look at the combo, as I said. Yeah, I don't need it. Let's look at the combo. Here's a combo for you. Order of operations. Base function, or basic, whatever you want to call it. Which function? Very good. Number 2, in order of operations, it has to be x minus 3. In order of operations, the next one has to be multiplication by negative 1 outside. And in order of operations must be this plus 2. This is the correct order. I know you're going to say this is right 3. I know you're going to say that this is a transformation on this, which is a reflection from positive y to negative y with respect to the x-axis. And this is up to. I'm going to follow the steps and create step-by-step everything. And I will start. I'm sorry?
Where's the third step?
Some people can count. I wasn't trying to check whether you were asleep or not. No. 3 doesn't exist for me today. I had 3 here. No, I'm sorry. I just... No excuse. Thank you. Thank you. Thank you. Thank you very much. My apologies. Okay, so here it is. I start with the base function. Let's see how handy my colors come in here. The absolute value of x. We are shifting it 3 to the right. 1, 2, 3. Shifted 3 to the right. Then we are going to reflect. I'm reflecting. This is the graph of negative, the absolute value of x minus 3. And then I'm going to shift this graph up 2. So this is the absolute negative, the absolute value of x minus 3 plus 2. Can anyone give us the range? We haven't even actually graphed the function. Transformations are just we used to quickly come up with a graph. It's not a perfect graph. I did not identify the x and y intercepts. I don't really know where it crosses. I don't care at this point. I just need to have a quick graph so I know how it looks like. If I put it in the calculator and I don't get this, I should say, oops, something is wrong. So what is the range of this function? For the range, we start from the lowest to the largest. Right?
Negative infinity to 2.
Negative infinity to 2. Is everyone in agreement with this? Yes? Okay, last one finally. Stretching, shrinking. We're going to talk about the vertical one first. I should have not told you that. But I'm sure you'll figure it out in a blink. Okay, so let's say I have f of x, which is 2x squared. And I have later on g of x, let's say 1/2 x squared. Which function did I use as the base function or basic function?
Quadratic.
Very good, x squared, excellent. So see what happens when we graph x squared, we get this graph. And each height now is multiplied by 2. So obviously it's a transformation on y because x squared and x squared are untouchable. The same thing. So it must be a transformation, it's outside. You can say, but it touches x. Not really, because first you have to square this and then multiply by 2. So it's outside. So it's a transformation on y. So change in y. Definitely. So here's what happens. The graph stretches. In other words, we can say the sides come closer together. It's a vertical stretching of the graph. So vertical stretching by a factor of 2. So this is twice x squared. And this is a vertical stretching. Now, the other one, obviously, is considered a vertical shrinking of the graph because it opens up more. Now, all the heights get divided by 2. So here's the graph, exaggerated a little bit, of 1/2 x. This graph is 1/2 x squared, which is a vertical shrinking by a factor of 1/2. So any number that multiplies, like here's a combo. Let's look at the combo. Let's say f of x equals 2, the absolute value of x minus 1, and plus 4. Now we can see this graph, right, in a blink. Here's the graph of the absolute value of x. We're shifting it 1 to the right. Here's the graph, so let me write this as the absolute value of x. Then the graph of x minus 1 in order of operations. Since I'm multiplying by a factor of 2, all heights will be doubled. So this is now twice the absolute value of x minus 1. And then everything goes up 4. So up 4, 1, 2, 3, 4. So right here, here's the graph. And this is the final graph. What will be the range? Very clear. 4 to infinity. Okay, the last one is the opposite of what you would expect. Everything else, I think, it's straightforward. The very last one is the opposite of what you would expect. So I'm on 8. Okay. So a function of twice x, you would say, oh, it's clear. You are replacing x by twice x, so you will be stretching it horizontally. No, it's the opposite. It's horizontal shrinking by a factor of 1/2. This is the only one that is against what you would expect. I would say that the other ones are straightforward. And what about f of 1/3 x? You would expect to divide each x by 3 and make it horizontally smaller. No, this time is a stretching by a factor of 3. Not shrinking, it's just the opposite. So horizontal stretching by a factor of 3. Okay, having all those said, on page, if you want to open multimedia library, I just printed these out, page 295, and then I would like to look at a word problem. I think we have no difficulties with the numerical ones. Let's look at one with a graph. So quickly, looking at problems 45 through 52 on 295. And I'm going to copy the graph. It's a very simple graph. It crosses here at 2. It's here again at 2, 3, 4. Crosses at -2 and goes to -2 at -4. That's it. This is the graph of function f. And let's choose, so it stops here. Cross is here, -2. This is -4. Of course, 2 and 4. And this is 2. Okay, so let's look at few situations. But I would like to start with 50. In 50, we're asked to find or graph 1/2 f of twice x. So this is the question. Graph f of twice x and then multiply by 1/2. That's the correct order, the order of operations. So when I graph f of twice x, which is my first step, number 1, I know that when x is multiplied by 2, it does not mean this. It means this. So every point of interest, its x-coordinate for the x-coordinate of every point of interest will be divided by 2, not multiplied by 2. So this point is above -4, so it has x equals -4. I divide -4 by 2, so then this point will transfer here. This point, which is at -2 for x, I have to divide its x-coordinate by 2, therefore it will move here. This point has x equals 0. It cannot go anywhere, because even if I divide 0 by 2, it will still not go anywhere. This point is when x is 2. I have to divide its x by 2, so we will move at 1. And this point has its x 4. I have to divide it by 2, and it will move here. This is the graph of f twice x. F of twice x. It was a horizontal shrinking of the graph by a factor of 2. All points had their x value divided by 2. Now, I have to determine or graph the function that starts with this, and it has all y values also divided by 2. So division by 2, because it's the y transformation on y, that doesn't change. It's not the opposite. Only f of twice x is the opposite, but 1/2 in front will divide all y values by 2. Okay, so now I'm looking at this point. This point is at the y value of -4. I have to divide its y value by 2, and it will go here at -2. This point has the y value 0. It cannot go anywhere. This point has y value 2. It must go to 1. This point has y value 2. It must go to 1. But this point has y value 0. It will have to stay. So here is the graph of 1/2 f of twice x. The pink one. 1/2 in front. Okay. I'd like to look at a word problem. And we're given the function here. So this is a word problem with the function. But I don't want to look at the function just yet. First of all, let's look at this graph and say, I think I can fit a function through it. And which function will you consider fitting through this data? So we have the height of boys at 10 months, 20 months, 30 months. So they plotted 1 point here, 1 point here, 1 point here, 1 point here. And then they fitted this graph. So now the question is, which basic function would you think of applying here if it works?
Linear.
Say it again.
Linear.
One more time.
Linear.
One more time. Hold on.
Square root.
Excellent. Yes, we expect when we see that the data that we have plots something like this, we do expect the square root to work. Obviously some transformations, because the square root is this, maybe a factor in front, maybe a vertical shift, but definitely I can identify now, I played with these functions already, so I know that this, a kind of a shape like this is definitely a square root. Even a shape like this will be a square root with a reflection and a shift up. So now you know so much about functions by simply going through this 40-minute lesson. Okay, so now let's read the problem and answer the questions. Let me